That sound is going to fill me with joy for years to come. Welcome back, everyone. There are maybe slides coming up because we have another talk, and it's Dan. And we're going to be talking about Stream and HTTP response. If there's time, Dan will take questions, but for now, clap, please.
Just a moment. Yeah, okay. All right. Hello, everyone. So I'm here to talk to you today about two things that I particularly love in Django, async support and in particular a new capability that Django 4.2 introduced, and also HTMX, a lovely little library. I'm kind of curious how many people are familiar with HTMX. Okay, it's a little less than I thought. I'll touch on it. Over the past year, I've been working towards trying to reduce my dependency on custom JavaScript code and jQuery and things like that. And HTMX is one of the tools I've been using a lot to do that. One area that I've been wanting to improve is real-time notifications, and so that's what I'm going to be talking about today. And so just briefly about myself, I'm a consulting software developer. I've been writing software in Python for about 18 years now. And I have never given a talk before, by the way, so sorry if I'm a little nervous. Recently I've been mostly working on bookings and reservation systems. My background's actually in telecom, but for some reason I've moved into bookings and reservations. Django is my web framework of choice and has been for at least 6 years now. You can find me on the Fediverse, Lucid Dan on Fossidon, and on GitHub. And rarely on my blog, which, like a lot of people, I am terrible at updating regularly and constantly promise myself I'm going to do better. The new functionality that I wanted to talk about in Django 4.2 is relating to the streaming HTTP response class, which has been improved to support async iterators, which is a very brief phrase that actually kind of masks the fact that it does something quite cool. It finally allows us to do long-lived HTTP connections inside native Django. That allows us to do things like server-sent events, which I'm going to talk about a little bit more in a minute. One thing that is worth noting is that this only works with ASCII servers, so when Django is running under ASCII, that means it has to be running in an async mode. If you're running a WSGI server like GUnicorn or something, Django 4.2 doesn't support this particular feature. So you would need to be running Daphne or Uvicorn or something like that. Sorry, I lost my place. Yeah. Just okay. Yeah. So when Django 4.2 came out, I already had a simple little custom ASGI application that I was using to handle server-sent events, which is a long-lived connection to send essentially push notifications to browsers, and I was using this in a few places. It used Django Channels. It runs side by side with Django in ASGI mode. Uses Django Channels URL router, which allows me to have different applications, and did some clever but kind of dark magic with regards to accessing Django's session data from inside another application to authenticate that somebody was actually logged in. Worked fairly well, but it was very much not pretty. Anyway, so this little application passed real-time events from a queue in my server, in my Django server, through to a front end, and then some custom JavaScript took that and rendered that into, I think it was Popper.js style popovers that would appear on the in the client's browser in real time. So something happens on the server side, and immediately someone would get a notification on their browser window. But it was kind of messy. So with Django 4.2, hopefully that's readable, yes. So with Django 4.2, I was able to quickly and easily replace all of that code, actually completely rip out channels, because this was the only thing I was still using channels for, and reduce it to barely a page of code. So I'm going to go through a little bit more what this code actually is and how it works, but essentially what's happening is I'm now doing my server-sent events in a native Django view. And what that enabled me, so that was an improvement in terms of just reducing the amount of code dependencies, getting rid of channels, simplifying a bunch of things. But then I soon realized that there's actually some other possibilities that become available to me by moving to a native Django view. So one of those is template rendering. So now I can actually take advantage of Django's template rendering, and I can directly render a template as a partial that I'm sending down this SSE connection, and use HTMX, which is designed to take little snippets of HTML and insert them into your browser DOM. So this got me really interested, because I for a long time was moving into the world of doing React front-end development, and more working with a lot of JavaScript-heavy applications on the client side. And I got to the point where I was starting to think, well, maybe this is just the way the web works now, and started rebuilding some plain websites in Next.js and stuff. But in the back of my mind, I was always a little frustrated with the complexity of all of this stuff, and I wanted to try and simplify things back down again. So being able to remove a bunch of JavaScript from my front end is something that makes me very happy, because I'm finding that there's just too much complexity in front end applications these days. So when it came to the notifications, the idea of ripping out all of the JavaScript code that I had on the client side, replacing that with essentially a Django view, some templates, and some HTMX tags to tell HTMX to do all of the work for me, was a really appealing idea. It's probably possible that I could have actually done this before Django 4.2 using Django Channels and things, but it would have been much more complex. I would have had to do some really messy things with trying to access Django's templating language or use something else like Jinja. It just would have been a lot more complex. So being able to do it this way, it turns out it's really simple. But before I get into the specifics of what I built and how that works, I just wanted to touch on the topic of why stream real-time notifications at all. So just taking a step back for a moment, why do I even need real-time notifications? A lot of the time, trying to do things in real time is a lot of extra work. Real-time software is hard, and it doesn't always provide all that much payoff. So most of the time, we're probably just better off polling or just waiting, just basically not worrying about it at all, and just do your messages, use Django messages framework, and set up all your messages, and then when you get your when you send your request and the response comes back, all of the messages will be there in that response, and just not worry about doing things in a real-time way. So There's nothing wrong with that. That's fine if, and that would actually be the end of my talk because, but with a lot of the software that I've been working with in bookings, particularly during COVID, stuff changes a lot. When you have a team of people working on bookings, there's a significant improvement in the user experience if they are able to see what's happening. So, for example, if you have several people organising bookings for a single trip, and that trip suddenly the border restrictions change, or something else changes, or there's a surge, or whatever. Being able to, for the booking administrators, being able to see that something's changed or that people are suddenly updating a whole lot of bookings is really useful. So it improves their user experience. So in that sort of scenario, there actually is a good use case for having that kind of real-time notification. One of the other things that's a problem with real-time notifications is trying to scale that up. Trying to handle hundreds of users can be challenging. Fortunately, with these particular applications, generally I'm talking about 10 to 20 users at most. So it's a relatively small number of users, so I don't have to worry about some of those scalability issues. But it's worth being very clear about this, that there is definitely a significant overhead to doing things in real time, to trying to stream updates and that kind of thing. So not everyone's going to want to do this, and if you need to scale it up, there are definitely challenges. I'm not going to cover very much of that in this talk, but it's worth considering, and it's worth thinking about if you are interested in implementing what I've built here. It's worth considering whether you actually need it, and look at are you going to have to try and deal with those sort of scalability issues? Just to illustrate, if you have 100 active users on your system at the same time, you're going to have 100 connections, streaming notifications for all of those users, and you're going to have to maintain 100 connections to your queuing system. And so there's just a lot of additional resources that you're adding to your setup. So your mileage may vary. The thing I'm talking about here is server-sent events. So one typical question might be, why not use WebSockets or some other sort of cool tech, whatever that might be. I'm kind of old and I don't really know what the latest things that people are using in the JavaScript world are. I know they have a lot of cool stuff that they're doing, but I kind of exited when GraphQL was getting popular. So SSE has been around since 2004. It was originally proposed. It actually rapidly made its way into browsers in its earliest iteration, and it has been there ever since. So it is probably one of those things that's had very good support for a very, very long time. And it's actually does not really seem to be used all that much. It's very, very simple. It is literally just a long-lived HTTP connection with a particular structure to the messages in it, which is basically a blob of text prefixed with data and a colon and terminated with 2 new lines. That's it. There's some other bits and pieces. You can have like event names and things and some other metadata in there, but essentially in its most simple form, that's all it is. It's just a very long-lived connection that just sits there connected to the browser and allows you to just periodically send little blobs of text to the browser. It's very well supported by HTMX, and it allows you to do things in HTMX and it works very much the same way that normal HTMX, everyday HTMX works. So HTMX mostly works through allowing you to use HTML tags to trigger AJAX requests, and then use those use the responses from those AJAX requests, which is just simply HTML, to then inject into your page. So the SSE functionality works the same way. Every piece of HTML that you send down through the SSE connection, HTMX grabs it and goes, okay, is there a place for me to put this on the page? And inserts it. And that's it. It's very simple. There is WebSocket support in HTMX as well. I have not looked at it at all because I just haven't needed to. So, so now I'm just going to spend a few minutes going through the looking at what it's actually doing. It's just demonstrating it, and then looking at some of the code and just talking about how it all works, and hopefully it comes across that it's very, very simple. So there is a link there to a repository, which is just a very simple Django application. There's a Docker file there. You can Docker build it. You do need a Redis server running. I haven't actually set that all up properly with a Docker Compose, so you would actually have to have a Redis server loaded up. But essentially, it should work mostly as is. So if I just, this is the tricky part where I switch to a mirrored screen, and everything possibly goes wrong. No. Good, okay. So I just have the demo application running locally, which is from that GitHub repository, and it's really literally just, I've disabled authentication sessions. I've basically stripped everything out that I can to make it as simple as possible, and it is literally just a button that sends an event, sends a notification. So basically submits to the Django server submits a notification into the queue, and then the queue spits that back out through SSE to each session, each browser that's connected to the application. So if I click this button here, both browser sessions get a copy of that, and you can actually see I've actually connected to the SSE URL at the back there. So this events/toasts, and that's actually each time I generate an event, that's actually, when I was talking about the blob of text and the data and the new lines, that's literally all it is. That's all SSE is. And so all that's happening is, each time I do this, HTMX picks up that blob and says, oh, okay, that's a div, and then it appends it to a container, which Bootstrap is then rendering as a toast on the display. And I can close those down and add more. And you can actually see each time down here, you can actually see that a new entry is being created there. That's literally all it is. But that allows me to generate real-time notifications, broadcasts, or targeted to specific users, and just so. Inside that demo, the code that's running in there, so this is just a piece of the template for the main index page, and that is this. Yeah, so this is this div here, toast container, has an attribute. This is all HTMX attributes. So these attributes basically say, enable the SSE extension for HTMX, connect to this URL, which is the /events/toasts URL. This just tells it that it's just a plain message. There's no event name or anything. It's just data : and then this HX swap just says, just append every time you receive a piece of HTML from this connection, just append it to the end of this div. And so literally all it will do is every time something comes in, it'll just insert it into the bottom of the div. You could do this in JavaScript. You could code this up yourself and write custom JavaScript to do this. And in fact, that's what I was doing before. But by using HTMX, I can literally just do it with a couple of pieces of HTML, which is really, really nice. And at the top there, those are the scripts that contain the HTMX code. The HTMX code is tiny. The SSE code is about 6 to 8 kilobytes. HTMX is a little bit bigger, but it's still under 50 or 60 kilobytes, I think. So it's very, very small, very unintrusive. So in terms of the streaming HTTP response part of things, which is the so I don't actually have that on the page here, but what happens in the view is that the view basically just returns a streaming HTTP response, which has a streaming content equals async iterator, or streamed events, which is this async iterator. So this is that new feature that I mentioned at the very beginning, the new feature in Django 4.2 that supports async iterators for streaming HTTP. And so all this code is doing is just connecting via Redis to a pub/sub queue, subscribing to events for toasts, which is the for the URL that we have, events/toasts. This will subscribe to toasts. It will go and wait for a message to arrive. When a message arrives, it'll decode it, grabs a template variable and a context, renders that into a string, and then delivers it back to the client through the SSE connection. So there are probably security issues. There are probably HTML escaping issues. I haven't gone digging around in all of that. But it's a good demonstration of just how simple this can be. Like, it is literally all you need. And then in terms of doing the notification, it's equally simple. So this is just a utility function that allows me to say, I want to send a notification. This gets the Redis client, says, publish an event to the toasts. So if I say event is toasts, and then it just encodes a JSON string with the template and the context, which contains the subject and the message. And the default template is just this demo/toast.html template. And this is just a sample of that template. So the template is basically some bootstrap HTML and CSS that just is basically going to render a subject, a message, time, and a message in the body. And that's basically all it is. So oh, and sorry, there's still one tiny piece of custom JavaScript that I need, which is essentially just basically the same thing that you would normally have with a Bootstrap toast. And I only actually have to use this in the Bootstrap code on one of my clients' sites. We're actually using Tailwind and Alpine.js, so we actually don't have to do even this. But this just basically tells it, anytime you see a div get created with that with the toast class, just go and set up a proper Bootstrap toast so that it will appear on the screen and you can close it and all that sort of interactions. And that's the only custom JavaScript on this whole application. So yeah, I do have some other notes. Probably the one that's really worth mentioning. In Django 4.2, there is still this thing with streaming disconnections. This is fixed in Django 5. I'm very happy to be able to say I saw that was fixed just recently, or at least I saw it recently. I don't know if it was fixed recently. But essentially, you get these messages, and actually, you can get these even unrelated to this particular stream, like server-sent events. Sometimes with ASCII servers, you just get this took too long, shut down, and was killed. So in Django 5.0, they've added support for task cancelled exceptions. So instead of the ASCII server just timing out and spamming you with all of these errors every time there's a disconnection, it will actually give you an opportunity to clean up the connection and close things down cleanly. So that's very nice. And I'm just a couple of other small notes, side notes. We use Redis for this. So the reason we use Redis was because we already have caching and task queuing in Redis, so it just made sense to use Redis as well. The Redis package is amazingly simple to use. The latest Redis version has async I/O built in, so you don't even need a separate package for it anymore. You used to need AIO Redis or something like that. So it's now very, very easy to use, and I've been very happy with that. There are other options. One that definitely deserves a shout out is, I think his name is Vidia, or I think it's Vidia, at Valberg. So he did a blog post about the same time as I was writing the blog post for this talk, which is when I decided to do it as a talk instead. So he basically blogged about almost exactly the same thing, but his implementation used Postgres and used listen and notify. So there's actually functionality inside Postgres where you can essentially build a queue in PostgreSQL, which is quite cool. I'm sure the scalability issues are much more pronounced than with Redis. Postgres is notorious for running out of connections, but it's a very interesting solution for small deployments. So that's worth taking a look at. And of course, there are other queue implementations that would work of various types. And you could just use async IO queue, but I definitely do not recommend doing that. That's a path to madness. And I think I might stop it there. My last couple of slides are not really relevant. So yeah, that's all.